Introducing the most feared living creature in the world, considered to be man's greatest enemy. On the surface, it seems highly primitive, but in fact, it's an astonishingly efficient and sophisticated creature. A complex machine out to colonize our planet. An enzyme factory capable of foiling all of its opponent's cunning tricks as it relentlessly pursues what we see as a purely destructive mission. Of microscopic proportions, the microbe is too tiny to be seen by the naked eye, but in terms of numbers, it's a giant. Our bodies are teeming with bacteria. Our skin crawls with billions of these invisible visitors. They're on our hair roots and in the corners of our mouths and eyes. The microbe divides every 20 minutes, forming huge armies of its kind, clinging colonies of infinitely reproducing clones. More than anything, bacteria adore our damp mucous membranes and our 37 degrees Celsius bodies. Our bodies are perfect havens to these organisms. They have colonized them since time immemorial, along with mud and the 7 seas. The more they have to eat, the more numerous they become. In fact, our bodies contain 10 times more microbes than cells. We can even say that within our own bodies, we are a minority compared to these creatures. Paradoxically, for such a small being, the microbe sometimes seems like a giant, towering over our tiny, fragile structures. Most bacteria are harmless. Some are even an absolute necessity for our organism. For example, food would remain undigested in our intestines if these billions of helpful little workers didn't break it down. Of all the numerous species of bacteria, only a few are dangerous to the human body. They produce toxins and multiply, causing health-threatening infections. Staphylococcus, pneumococcus, and streptococcus cause blood poisoning, pneumonia, and tuberculosis, diseases that have riddled the history of humanity. Our history is scarred by the merciless war waged between man and bacteria since the beginning of time. More than anything, the microbe represents trauma. It's the painful memory of all those we have helplessly watched die before our very eyes. Over thousands of years of epidemics, the invisible enemy has claimed countless victims, mainly among the weaker and poorer members of society. It's as if the microbe specializes in causing grief among families.
So it's hard to imagine what life was like before antibiotics were around. In the 17th, 18th, and 19th centuries, life expectancy was 30 to 40 years of age. People were usually killed by infections, tuberculosis or pneumonia, and all kinds of illnesses that are easily cured today. It was also very frequent for newborn babies to die of infections. So death by infection was a common thing, and there was virtually no treatment available for it. A perfect example is syphilis. There was a high mortality rate for this infectious illness. The treatment for this disease used to be mercury salts, which were extremely toxic. There was even a saying, "One night with Venus, a lifetime with Mercury." Arsenic and heavy metal salts were tried after that. Many people don't even know that up until 1945, doctors even used a parasite responsible for causing malaria called Plasmodium. The antibiotic discovery process took a new turn when scientists realized how bacteria and viruses influence the spread of infectious diseases. Back in 1880, nobody knew where infectious illnesses came from. They thought they were of genetic origin. They had vague ideas about contagion, but bacteria as a source of infection were totally unknown. Pasteur and Robert Koch in particular discovered the infectious agents responsible for tuberculosis and cholera. All the big diseases were discovered around this time. Then, the next problem was to find out how to treat such diseases, which almost always killed their victims.
Thanks to the first modern scientists, we were finally able to identify our microscopic enemies. But knowing how to stop their proliferation was a whole different story. Man also realized how keen microbes are to live among us, crawling around us at close quarters and enjoying the dirt we leave behind. Bacteria also love crowds. They're always eager for a chance to jump on new victims in moments of close contact. We then began to view even the most harmless of actions as a potential source of danger. Microbes will go to any lengths to extend their empire. Body contact, saliva and sneezes are not their only means of transportation. They have also developed a few methods of their own, enabling them to invest new territories. Bacteria have a particular liking for war and human exodus, as these are prime opportunities for it to multiply among the masses and single out choice, famine-struck victims. They also have a liking for our large industrialized cities, as these are synonymous with huge concentrations of humans. The spread of the modern world gave bacteria new techniques for moving faster and further afield, allowing them to continue sponging off human hardship in order to spread their empires. During this very long period before antibiotics were invented, bacteria were man's arch-enemies, and he tried everything and anything to come up with a miracle cure for these tiniest of tyrants. It would not be before the 1920s that Sir Alexander Fleming would discover a first remedy. Antibiotics have become so common in daily life that modern man sometimes thinks they've been around forever. The antibiotic is the first cure capable of striking down the microbe. The only truly magical remedy in all of man's history, long awaited by doctors and patients alike. It's the key to modern society, a world where microbes are almost a thing of the past. In the space of just a few years, the antibiotic became one of the pillars of the modern world. Man can no longer do without antibiotics. Its enzymes are capable of achieving hitherto impossible feats, penetrating the microbe wall and killing the bacteria from the inside. The results are nothing short of spectacular. Western man has been quick to forget about the past, when microbes had the upper hand. He has become an antibiotic addict who demands immediate relief. People have almost begun to take health for granted. And for a modern society constantly on the go, the miracle fever reliever has become one of man's best friends. For years now, we have been using antibiotics non-stop to cure almost all illnesses. We wouldn't even consider taking a trip without packing the leftovers of a past prescription for a cold or a stomach bug. People have been doing this for years, but little did we know it would cause one of the biggest ecological problems in recent decades. For 60 years, thousands of tons of antibiotics were dumped into the environment. But while we were busy consuming huge amounts of antibiotics, the bacteria were patiently preparing their counterattack.
A very interesting observation was made by a key player in this process, one of Koch's students named Paul Ehrlich. He observed sections of tissue from patients who had died of infection under the microscope. They were found to contain bacteria. He colored them with dyes derived from a chemical product of coal called aniline, and he noticed that the tissues sometimes remained unaffected, but that the bacteria always changed color. He concluded that it may be possible to kill bacteria selectively using colorings. In fact, the discovery of antibiotics has a lot to do with colorings. So, inspired by the coloring industry, researchers started testing tar waste, 200 chemical products or more. In the 1860s or 70s, they found various products capable of reducing fever. All these compounds came from carbon, such as carbon waste or tar. Then they looked into the possibility of using colorings to combat infection. This wasn't problem-free, as some colorings are very toxic, but they did realize they could be used to kill microorganisms. The big pharmaceutical companies that had sprung up along the Rhone and Rhine rivers were instrumental in this. In fact, the discovery of the coloring stimulated research.
Antibiotics did not make their debut in the 1930s as we have often believed. They date back to the origins of the planet 3 billion years ago. They are as old as bacteria. In fact, bacteria actually invented antibiotics. For about 2 or 3 billion years, bacteria were the only inhabitants of Earth. If we use Paris's Eiffel Tower as a timeline for the history of the Earth, bacteria would have appeared at the first floor. They remained alone on Earth for a very, very long time. In fact, until about the third floor. The first dinosaurs would have appeared slightly higher, and humanity would hardly even represent the thickness of the coat of paint covering the tip of the tower. For 99% of its history, our planet has been inhabited exclusively by bacteria. In ancient times, Earth was totally covered in water, forming what is known as the primeval soup. Single-celled algae reigned supreme. They loved water and light and already carried out photosynthesis.
One of the major changes that were introduced was an ingenious invention known as photosynthesis. Solar energy that radiates onto the Earth is just about the only source of external energy. This energy has to be converted. And bacteria are the only living organisms capable of doing that. And by doing that, by changing carbon gas into oxygen, they provide us with energy. And that is what enables us to breathe. If you look at the universe as it stands today, Earth is the only planet known to contain life. And what really sets Earth apart from other planets is that it has oxygen in the atmosphere. And that oxygen comes from microbes such as algae and bacteria.
By performing photosynthesis for billions of years, bacteria brought about the greatest ecological revolution of all time. They gave off huge amounts of oxygen, wiping out most living species at the time, in other words, other bacteria. Only the microbes that were able to resist the gas survived. When the quantity of oxygen stabilized, a layer of ozone formed around our planet, shielding it from high-energy ultraviolet rays. It took the bacteria several billion years to create the atmosphere we now breathe. Mankind and every animal species on Earth would never have existed without their painstaking work.
In the same way, we need energy in order to perform any physical movement. We eat sugar, for example, but then we need energy to burn that sugar. We get the energy we need for this from mitochondria, present in our cells. Our muscle cells, for example. Well, we now know with certainty that these mitochondria are none other than bacteria. A very long time ago, maybe 2 billion years ago, bacteria were absorbed by cells, where they took up residence. A kind of symbiosis was established between the bacteria and the cells that had consumed them. Now a mitochondrium, the bacterium needed the cell in order to live. In return, this mitochondrium bacteria inside the cell enabled the cell to utilize energy, which it could not produce by itself.
The occupying bacterium allowed its host to live in an oxygen-filled environment. And so emerged the very first animal cell, the common ancestor of all animals and humans on this planet. All inhabitants of planet Earth have a bacterium in each and every cell, enabling them to breathe oxygen. But the genetic genius of microbes goes even further. In this primitive world, where each microbe jealously defended its territory and its food from rivals, bacteria actually invented the antibiotic. An antibiotic is an enzyme produced by single-celled organisms to destroy their opponents. In this hostile world, where each microorganism wages a territorial war, bacteria attack and counterattack each other with enzymes. The antibiotic is an ingenious invention, courtesy of the microbe. Man is also keen on territorial conquest, but during the historical period between the two world wars, he had still not found a cure for bacterial disease. Before he'd even made this major discovery in the field of health, he was already engaging in bacteriological warfare. Man learned how to kill with microbes before he even knew how to defend himself from them.
All manner of playful little germs to inflict horrible disease on whole cities.
Mankind may not have bacterial enzymes for conquering territories, but it certainly has other technical means. The 1930s were a very active period in terms of scientific research. Man's dream of ruling the world was stronger than ever before. In 1920, a humble bacteriologist by the name of Alexander Fleming made a very strange discovery in his lab at St. Mary's Hospital, London. After applying his own lacrimal fluid, in other words, his own tears, to a germ culture, he noticed the appearance of large indentations in the bacterial colony. He named this phenomenon lysis, and went on to develop lysozymes from tears and nasal mucus. But this first natural man-made antibiotic was ineffective on truly pathogenic bacteria, and the project was abandoned. But 8 years later, in July 1928, Fleming, returning home from vacation, was to make one of the greatest discoveries of all time. Before leaving, he had left some Petri jars of staphylococci cultures in his lab. A strange mold had grown on them. The English scientist realized that he had stumbled onto something huge. The fungus had actually prevented the bacteria from spreading. Meanwhile, fellow bacteriologist Merlin Price was also carrying out research on natural antibiotics and was intrigued by Fleming's discovery. Fleming recognized the lysis phenomenon he had observed 8 years before. The mold he had just discovered was able to kill bacteria. The English scientist had just found what would be called the magic bullet, the miracle remedy that doctors from all over the world had been waiting for. In the days that followed, penicillin revealed its revolutionary properties. One of them being that it was not in the least bit dangerous to animals. Before long, Fleming was able to carry out his first tests on human material. Around this time, his assistant, Stuart Craddock, was suffering from continuous colds and conjunctivitis. He became the first man on Earth to benefit from penicillin. We don't know whether or not young Craddock was cured by the treatment, but he certainly suffered no adverse effects. He was extremely lucky, and so was the medical field, because we now know that in nature, only one antibiotic in 1,000 presents no risk for humans.
Vous savez, you know, wild mushrooms and certain bacteria actually produce antibiotics naturally. Soil is literally teeming with antibiotic manufacturing fungi. This struggle is the microorganisms' natural way of competing with each other.
Le pénicillium de Fleming.
The penicillium Fleming found is a soil microorganism. Unfortunately, Fleming wasn't a chemist, so the raw product he came up with was very unstable, and he was unable to show that it could be injected effectively.
Par injection. In
1932 or 1933, he gave up all his research into penicillin. What the project needed was a chemist in its ranks, combined with a businessman, someone who could get things moving. In 1939, Fleury started sifting through write-ups on antibiotic-related substances. When he came across Fleming's publication, he realized there might be something in it. So that's when he hired an ingenious man by the name of Ernst Chain, who joined Fleury's team. Chain was the one who started off by purifying penicillin. Fleury then tested this purified substance on mice. He managed to get a few contacts going and formed a team known as the Oxford Group. Then he went and knocked at every available door, announcing that he had come up with a highly active substance named penicillin, originally discovered by Fleming, which was worth investing in. The English government and industrialists turned him down. So in 1940, he went to see the Americans, which proved successful because the Rockefeller Foundation gave him financial backing in the form of about £5,000, quite a sum at that time. This allowed him to really get his research underway. Then he managed to persuade several American companies to produce penicillin industrially.
Don't worry about it hurting them. Penicillin-injected rabbits are the healthiest in the world. They seem to enjoy their job of serving mankind.
Believe it or not, Fleury teamed up with an industrial beer brewer. He needed to produce penicillin on a wide scale, and brewers were useful because they had huge fermenting vats for cultivating bacteria, and because they had all the necessary equipment to turn the liquid obtained into freeze-dried powder form. That's how it all began. He managed to get institutional support, and doctors started trying out penicillin as a medicine from February or March 1941 with very positive results.
It was good news.
Then, in 1941, along came Pearl Harbor. From that moment, American industry and the Army invested all their energy in penicillin, producing it on a massive scale. At first, it was issued to the American troops. Then, much later, it was made available to the general public. It was a revolution boosted by the Japanese attack on the U.S. troops. It jolted the American Army and government to back penicillin very actively.
LCVPs moved in close to the obstacle barricade and dropped their ramps. Troops waded through deep water to the shore. Many never reached it. We landed more medical field units. The severely wounded were carried to the relative safety of outlying hospital ships and transports.
Penicillin saved its first few thousand lives. The miracle of medicine had made its debut.
But you have to realize what penicillin meant in 1945, which is when it came to France. It was so expensive that when one patient was treated with it, their urine was collected, and the penicillin contained in it was purified and injected into another patient. This went on from 1945 to 1947, when penicillin was a very scarce commodity.
But the miracle drug did not eradicate all of man's bacterial enemies. One plague remained impervious to Fleming's discovery.
One major disease, tuberculosis, was widespread at the time. It was responsible for a lot of deaths at the beginning of the 1900s.
Before the discovery of antibiotics capable of destroying Streptococcus, man's only means of fighting disease was health and hygiene. Tuberculosis wreaked havoc among the poorer members of society directly before and after the Second World War. With no effective medication available, sanatoriums served basically just to keep the sick out of circulation.
Each white bed is filled with a young, feverish body asking to be kept alive. Tuberculosis has severely struck children weakened by war. 6 months of rations and poor heating are to blame for their condition. The anti-tuberculosis stamp you will all be buying this week will lengthen the lives of French children. Give generously. Our offspring must be able to breathe pure air, to have their youth, health, and optimism restored, so they can grow up and keep our country strong. From about 1942 onwards, when penicillin gained success, researchers systematically started working on soil bacteria. Bacteria were isolated, then hundreds or thousands of microorganisms were screened. This is still done today, in an effort to find a substance that will naturally produce an antibiotic when in contact with a specific microorganism. The antibiotic is then purified and tested for toxicity. In the case of tuberculosis, a very intriguing observation was made. It was observed that the microbes responsible for causing tuberculosis could survive perfectly well in soil, but that they were destroyed within 15 days when placed in manure. It was obvious that manure or sewer water contained microorganisms which had a very strong effect on the TB germ. So researchers started investigating further. A macrobiologist specializing in soil bacteria named Waxman went on to discover streptomycin with the help of his student. They tested hundreds and hundreds of strains of the Streptomyces fungus. One of the strains was found to produce a particular antibiotic, which was proven to combat tuberculosis. They named it streptomycin after the fungus.
I've been notified that I've been awarded the Nobel Prize in Medicine. I feel particularly proud for the field of science which I represent, microbiology.
By striking down tuberculosis and meningitis, mankind had achieved the second true revolution in the medical field.
The streptomycin injections that resulted from this research proved to be a very efficient cure. Doctors were so amazed by the results achieved on the first patients treated that they thought they must have diagnosed the illnesses wrongly. They thought it couldn't possibly have been tuberculosis meningitis because it's so hard to treat. Nowadays, tuberculosis meningitis is 100% curable, so it's hard to imagine the impact the treatment had at the time when doctors had been so used to seeing patients die from the disease.
Penicillin and streptomycin were to become the cornerstones in the antibiotic empire by the end of World War II. After many years of restraint, the pharmaceutical labs started investing heavily in research and production. These molecules were used to make new, improved antibiotics. Man naively started to believe he had done away with the microbe for good.
It's important to understand, from the very beginning, antibiotics were seen as miraculous remedies. Up until then, some diseases had been killing infected patients very easily. Take the example of pneumonia from pneumococcus, which killed 90% of victims in its most severe form. Then all of a sudden, with just a few injections of penicillin, the death rate was reversed to just 10%. A complete turnaround. The equivalent today would be if a medication were to be isolated to cure cancer very fast, even for the severest of cases. Add to that the fact that the discovery of antibiotics was full of interesting anecdotes involving some amazing people, some of whom, like Fleming or later Florey, were very charismatic. And you can understand why it left a very deep impression on a whole generation of doctors.
L'esprit des médecins de toute une génération.
Because of the renewed peace, the Nobel Prize ceremony in Stockholm was the most solemn it had been since it had been created in 1901. King Gustav V rewarded English scientist Alexander Fleming and his assistants with a huge sum of money for their work in discovering penicillin.
Showers, thunderstorms, warm
Mom, is dinner ready?
All ready.
Chance of locally severe thunderstorms. Showers and
How about some dinner?
Yes, it's all ready.
night and cooler weather.
From the 50s and 60s onwards, antibiotics naturally and effortlessly became an essential ingredient of modern living.
Look how it shines. You did get all the soap out last night, didn't you?
Little by little, the microbe magically disappeared from our daily fears. Basking in the luxury of antibiotics, we entered a fantasy world free of infection. We thought that one of the darkest periods of medical history was finally behind us.
Once they realized what startling results penicillin could achieve, doctors started wanting to use antibiotics every time they thought they might be of some benefit to their patients. This brought a huge increase in consumption, which was justified by the extraordinary effects of this drug. Vets saw what was happening and started using antibiotics on animals. And they got the same miraculous results in the process. Farming is also affected by some bacterial diseases, a certain number of which can be eradicated with antibiotics. So farmers also started using these drugs in certain cases.
Et comme ça, au fil des années,
and so, over the years, antibiotics were perceived as unique, trouble-free remedies, which, into the bargain, were hardly toxic.
Et qui en outre étaient extrêmement peu toxiques.
They are toxic, but only to a very slight degree.
Mais elle est très faible.
As a general rule, they only yield positive results.
Et c'est cet ensemble
Because of this miracle combination of very great effectiveness and very little toxicity, it was generally thought that we could continue using antibiotics as much as we wanted, to cure whatever we wanted, on humans and animals, and in farming, without suffering any harmful consequences.
And that's exactly how the greatest ecological upheaval of all time occurred, without us even knowing. For 60 years, thousands of tons of antibiotics have been poured into our environment via our bodies, but also via streams, rain and soil, and the meat and the fish we eat. Antibiotics have now taken up residence on our planet, in no uncertain terms.
On average, every human being consumes about 10 grams of antibiotics per year. The result is tons and tons of antibiotics dumped into the environment. Now, bacteria do not like this one little bit. It causes them stress, and they're going to keep on resisting to the very end.
Bacteria have developed various techniques of resistance. One of them involves blocking their pores to stop the antibiotic from penetrating their protective membrane. Some resistant germs have another way of fending off an antibiotic attack. They send out special enzymes to destroy the medication before it can reach its target. Yet another counterattack technique consists of allowing the antibiotic inside its cell wall. Then, using a sophisticated pumping system to eject the intruder before it has time to act.
In 40 or 50 years, we humans have come up with 50 to 100 different antibiotics. And we see this as quite a feat. But in the same time span, microbes have invented just as many ways to resist our antibiotics.
Bacteria's ability to learn so fast comes from an age-old gift that is truly amazing. Although they have the reputation of being the most primitive species on the planet, these living organisms can transfer particles of DNA to each other simply on contact. In other words, when one germ knows a technique for thwarting a particular antibiotic's attack, it can pass the genetic code on to another individual for it to use in turn. This is how bacteria of all varieties, including some pathogenic ones, have become resistant to several antibiotics over the years. Bacteria have had no trouble in developing and sharing antibiotic resistance techniques. Naturally, because they have always lived in an antibiotic-rich environment and have themselves developed antibiotics in the first place.
Because we have used antibiotics in a wide variety of ways, on human beings, animals, and farming alike, it has sweepingly affected the bacterial world. That's why the ecological impact is so great. If antibiotics had selectively killed only pathogenic bacteria, there would hardly have been any problem. The hitch comes from the fact that bacteria as a whole have grown more resistant to antibiotics and have in turn taught disease-provoking bacteria the secrets of their resistance.
In the soil and in the air, bacteria keep on doing what they've always done, sharing acquired genes of resistance. The difference today is the speed with which the exchanges are carried out, and the distances covered by the germs, as well as the resistance genes they carry. Resistant bacteria are conquering our entire planet right beneath our eyes.